Hi, welcome to another episode of Applied Physics for Second Mid Exams. Myself, Dr. Sivanagi Reddy, and today we are going to see about Applied Physics objective question and answers. For second mid, the syllabus is like semiconducting devices, nanotechnology, and lasers and fiber optics. Out of 10 objectives, 2 objectives from semiconducting devices and 4 objectives from nanotechnology and 4 from laser and fiber optics. This here also we will get 2 plus 2. 10 objects, 10 marks. The range of wavelength for visible light. So basically it is 0.4 micrometers to 0.7 micrometers. Which of the following device converts light energy to electrical energy? So it is a solar cell. Solar cell converts a light energy into electrical energy, whereas LED converts electrical to light, and semiconductor laser also it will convert electrical to light energy only. Then when come to fiber optics transfers the light signals. What is the function of PN junction diode? PN junction diode conduct the current in one direction only. So it's act as a switch. In forward bias it will conduct the current, in a reverse bias it will make it zero. That is a ideal case, but practical cases we will get a very limited current in reverse bias also. Genar diode is used for regulate the voltage. So basically Genar diode is operated in reverse bias mode and it is used to regulate the voltage. The working principle of LED. LED stands for light emitting diode, electroluminescence. Solar cell will work on photovoltaic effect. Then most common type of material used for making solar cell is silicon. So mostly we will use the silicon for solar cell fabrication. The function of B.Tech, bipolar junction transistor, is amplify the signals. Photodiode works based on photovoltaic effect, where it will detect the light signal. What type of the current does B.Tech amplifies? It's a direct current. The main application of a photodiode is for light sensing. We will use the photodiodes. Even in optical fibers also we will use. 1 nanometer equal to 10 power minus 9 meters. The surface to volume ratio of a nanoparticles is high. The properties of nanoparticles can be explained by quantum mechanical concepts. Which of the following properties change if bulk material is converted to nanomaterial? Elastic modulus, hardness, resistance, all the properties will change. Nanomaterials are catalysts because of their enhanced chemical activity. Quantum dot is an example of zero-dimensional nanomaterial. Nanowires are examples of one-dimensional nanomaterials. Graphene or nanosheets are a two-dimensional. Bulk will be the three-dimensional. In a quantum confinement effect, the energy levels of atoms changes. The technique used for the fabrication of nanomaterials is ball milling, sol gel, chemical vapor deposition, all of these. So all of the methods we can use in order to fabricate the nanomaterials. For a cubic nanoparticle of a side A, surface to volume ratio is given by. So surface to volume ratio, if it is a cubic, surface area is A square and it has 6 sides, 6A square, volume will be A cube. So on cancellation we will get 6 by A. What is a quantum confinement in the context of nanoscale materials? The confinement of electrons to the limited space. In the fabrication of nanoparticles, bulk materials is crushed into nanoparticles in ball milling method. By reducing the size of a metal particles from bulk to nano, the energy bands become narrower. Nano-sized particles are chemically very active because the number of surface atoms are more. Bragg's law is given by 2d sin theta is equal to n lambda, where d is the interplanar spacing, lambda is the incident wavelength, n is the order. The crystal structure of nanomaterials is known by X-ray diffraction. XRD stands for X-ray diffraction. SEM stands for scanning electron microscope. So here we will see the morphology of the material. When come to CVD, chemical vapor deposition, and PVD stands for physical vapor deposition. CVD and PVD are the methods which are used to fabricate nanomaterials. This is 2R characterization techniques. The size range of the nanomaterials is, so any one dimension of the material is 1 to 100 nanometers range. Those materials are treated as a nanomaterials. In which fields are nanomaterials most commonly used? Biomedical, energy, environmental. So in most of the fields we use the nanomaterials for different applications. How do nanomaterials improve the performance of a solar cell? Increased surface area for light absorption, improved electron transport properties, enhanced charge separation efficiency. So all of the above is possible with the nanomaterials. In nanomaterials, with the decrease of the size, the melting point will decrease. Laser is an acronym for light amplification by stimulated emission of radiation. If an electron excites from the lower state to higher state, then the process is called absorption. So whenever two states are there and an atom absorbs the incident energy and go to higher states, that's what we call absorption. Whenever they are coming from higher state to lower state, that comes the spontaneous emission and stimulated emission. Spontaneous emission is a random process. So because at the higher level, the lifetime of a excited state is 10 power minus 8 seconds, so automatically it will come down. When come to the stimulated emission takes place whenever the external energy come into picture. Laser has a high degree of monochromacity, coherence, intensity. So everything is higher for lasers. In a helium neon laser, the ratio of helium neon gas mixture is 10:1. Under population inversion, the number of atoms in the higher energy state is compared to lower energy state greater. So population inversion will takes place only higher energy level has more number of atoms compared to lower energy level. In excited state, the atom will remain for a time period of 10 power minus 8 seconds. The population of various energy levels of a system in thermal equilibrium is given by Boltzmann law. Boltzmann law we use in order to explain. Population inversion cannot be achieved by chemical reaction. In a lasers, we can use optical pumping, electrical discharge, thermal process in order to get the population inversion, but there is no chance for chemical reactions. Which of the following is a coherent? Stimulated emission is a coherent process, whereas spontaneous emission is a non-coherent. What is the main material used in the construction of semiconductor laser? So gallium arsenide we will use for the construction of semiconducting laser. Optical fiber guides light waves by total internal reflection. The numerical aperture represents light gathering capacity of a optical fiber. If the refract indices of air, core, cladding are mu0, mu1, mu2 respectively, then so basically refractive index of the core will be higher, clad is less, and air will be lesser than these two. So mu1, mu2, mu0. Numerical aperture depends on acceptance angle because it is a sine inverse of acceptance angle. Total internal reflections takes place when the light rays travel from denser to rarer medium. The refractive index of a cladding of a fiber with a core refractive index 1.5 and a numerical aperture is 0.22244 is. So we have to calculate the refractive index of a cladding. So numerical aperture is given by core minus cladding. So we have to write N2 as a subject and substitute the values. Once we substitute the values, we will get 1.48. Pick out the losses present in the optical communication systems. We have a different types of the losses in optical communication system, which includes absorption losses, scattering losses, distortion losses, and all of these. The refractive index of core and cladding are 1.563 and 1.498 respectively, and then numerical aperture is same formula, whatever we used previously, that one only, square of the core and clad. So if we substitute these two, we will get, kindly cross check the answers, don't take it granted. Next one, step index fiber can be a either monomode or multimode, cannot be both. In optical fiber, numerical aperture is defined as a sign of acceptance angle. That's all for today. We will meet in another video in the next time. This is Dr. Sivanagi Reddy. Jai Hind.